Alright guys, so make sure you know how to do stoichiometry. So topic 4.7, types of chemical reactions. So the objective is to be able to identify a reaction as an acid-base, oxidation, reduction, or precipitation. So we talked about chemical reactions, chemical processes, and all that. So some of the things you need to be aware of um, for the AP chemistry exam is different types of reactions, and then be able to recognize oxidation numbers like we practice in 4.2 and all the type of stuff. So there are different types of basic reactions that we see in chemistry. So composition or synthesis, A plus B produces AB. Combination, composition, synthesis, decomposition. So AB breaks down to A plus B. Single ionic replacement, one more reactive element comes and kicks off another element, takes its place. Double ionic replacement, two uh, species switch places. I'm saying the nice version of this. Combustion of a hydrocarbon or a metal. So combustion means something interacts with oxygen and then it produces either, so if it's a hydrocarbon, so it's a carbon and hydrogen with or without an oxygen, forms um, reacts with O2 and produces carbon dioxide and water, or a metal interacts with O2 and then they combine together. So it's a combustion, but it's also a combination at the same time for that one. So the double ionic replacements, they can include the acid-base neutralization or precipitation reactions. Neutralization means acid-base react together, they form a salt and water. And then precipitation, meaning you produce a solid after the acid and base interact, and one of the other products goes into solution. All of these can be considered redox or oxidation reduction reactions, except for double ionic replacement ones, and we'll look at that in a bit. So acid-base reactions involve the transfer of one or more protons between chemical species. So we've talked about this before in honors, but a Bronsted-Lowry definition for an acid is that it donates protons and a base would accept protons. When we talk about protons, we're looking at hydrogen ions. When a hydrogen ion reacts with a water molecule, something called a hydronium ion forms. The terms proton, hydrogen ion, and hydronium are often used interchangeably, and you may hear me use one or the other, and it's all good, it's all the same. So conjugate acid is a molecule that can be described as a base that has gained a proton. If it's a conjugate base, that means it has lost a proton. In this example, we have water. It can act as a base or an acid, but for this one, it's acting as an acid and it's donating its proton to ammonia, which is considered a weak base. So water is acting as a Bronsted-Lowry acid, so it's going to donate its hydrogen to the ammonia, and then it forms an ammonium ion and then a hydroxide ion. So the Bronsted-Lowry acid is the water, then the conjugate base, because it lost it, because on the other side it loses, so that the hydroxide ion is considered the conjugate base, and the ammonium ion is considered the conjugate acid because it gained a proton. But this other example, water is acting as a base and it's accepting a proton, so it just depends. It can act as either one or the other, and therefore it's called amphoteric. So the term amphoteric means that it's a substance that can act as an acid or base, and water is an example of that. So we see that water in the second example is gaining, in the reaction, it's going to gain a hydrogen. So the HCl, hydrochloric acid, is going to be the acid, and then the water is acting as a base. So on the other side of the equation, the chloride ion is a conjugate base, and the hydronium ion is the conjugate acid because it gained a proton. Oxidation reduction reactions occur when you're transferring one or more electrons between chemical species, and you can see that is happening based on the oxidation number. So if you don't know your oxidation numbers, when you see whether it's a metal, if you see blah blah, and if you don't know that, you're gonna have a rough time. So combustion is a reaction a type of oxidation reduction reaction involves involves oxygen gas as one of the reactants. And in this case, like we said, carbon dioxide and water are the products of combustion. So oxidation refers to the loss of electrons, and reduction refers to the gain of electrons. So Leo goes Gur is something that people often use to describe this or to memorize it. So if it loses electrons, it is oxidation. And if it's gaining electrons, it's considered reduction. So let's look at the example below. We have a single ionic replacement reaction where we see that it's also kind of a redox reaction. We will write the net ionic equation. So copper 2 nitrate plus sodium produces copper and then sodium nitrate. So the overall ionic equation reaction, you break it up into its ions. So the copper becomes copper 2 plus, and then 2 nitrate ions plus 2 sodium ions produces copper, solid copper, 2 sodium ions, and then 2 nitrate ions. Nitrate ions go away, and you're left with the copper 2 plus the 2 sodium ions, so plus 2 sodium, I'm sorry, and it produces solid copper and then 2 sodium ions. So the copper ions were into copper metal, and the sodium metal was actually changed into sodium ions. The copper must have gained 2 electrons to form the copper metal, and this is reduction because it gained electrons. Each of the sodium atoms lost an electron to form the sodium atom lost an electron to form the ion. So it loses an ion, so this is oxidation. So it's important to know what's happening to your electrons. So the charge, remember that if it's a plus charge, that means it lost electrons. And if you have a negative ion, it gained electrons. But if your positive ion goes to let's say for this example, so your 2 plus goes to a 0 because now it's metal, or it's a solid, so to speak, is by itself. So for it to go from 2 plus to form the copper metal, so 2 plus to 0, that means it had to have gained electrons, so that's reduction. And then the other one, if it loses electrons to go from a solid with an oxidation number of 0 to 1 plus or 2 plus or whatever, that means it lost electrons, so that's oxidation. So know your oxidation rules. Oxidation numbers are always written above. Show plus or minus unless it's 0. They're always written for one of the elements in the question. The charge is always written first followed by the value. Oxidation numbers can also be fractions. Ugh, that's gross. So if it's an element by itself, it's a oxidation number of 0. So even O2, or it looks like carbon 60, 0. If it's hydrogen is in a compound, and it's always plus 1. Hydride is 1 minus. Oxygen in a compound is -2, unless it's peroxide, it's 1 minus. So these are stuff we've already covered already. Group 1 ions plus 1. Group 2 ions plus 2. Fluorine is -1. If it's a neutral compound, it's always sum of 0. And if it's a polyatomic ion, the sum of the charges has to equal the charge of the ion. Combustion reactions are considered examples of oxidation reduction reactions. So we're just looking here, you can see what happens from C2H4 plus O2 producing CO2 and H2O. So remember that when we're looking at these, you have to follow the carbon, so to speak. Or not follow the carbon, I'm sorry. Double check your oxidation numbers. Remember that if it's a solid, if it's a compound, it equals 0. If there's a charge for the ion, it equals that. So all of these should equal to 0 in the end, like C2H4, the combination of those oxidation numbers will give you 0, etc. So then you can kind of see from carbon that it goes from -2 to 4 plus. So what did it do? It lost electrons, so it was considered oxidized. And you see the oxygen is reduced because it goes from O to -2. Oh, sorry, 0 to -2. So it gains electrons, so it was reduced. Precipitation reactions, you have ions mixing in aqueous solution, and you're producing an insoluble or a soluble ionic compound. Sodium, potassium, ammonium, nitrate salts are all soluble in water. If you have a precipitation reaction, remember you're forming that insoluble product. That's your precipitate. Okay? You should always be able to predict the products of a reaction by recombining positive and negative ions. Sodium metal reacts with a solution of sulfuric acid, H2SO4, to form hydrogen gas and a solution of sodium sulfate. Write and balance the equation. So my stylus isn't working, but we do have a key for this, so it's cool. All right, so sodium metal, so NaS plus H2SO4 aqueous forms H2 gas in a solution of sodium sulfate. Okay. Assign oxidation numbers. So we know we have solid sodium by itself, so that's a 0 for sure. We have H2 gas, that's a 0 for sure. So you can kind of figure out based on what's going to happen with who's going to be reduced and oxidized based on the oxidation numbers. So sodium is 0, H2 is 0. So if we look at, we recognize that the SO4 together on both sides, no sulfurs or oxygens are kind of like put into another product, etc., or split up into two products. So those oxidation numbers are probably going to be the same. So the only thing that changes is actually H2 is the 1 plus, and it becomes 0 on the product side. The 0 from the sodium becomes 1 plus. So who's reduced? Who is oxidized? The sodium was oxidized, and the H in H2SO4 was reduced. Caffeine, ooh, my favorite, C8H10N4O2 acts as a base when dissolved in water. So it tells you that water is going to be an acid. Write out the equation for this reaction. Then determine the acid base, conjugate acid, etc. So it tells you that water is going to act as an acid. So it's going to donate its H, or one of its H's, I guess, to caffeine on the other side of the reaction. So in the process of water donating its H, it becomes what? The conjugate base. Caffeine accepts the H, but because it's technically 0, because it's accepting an H, accepting an extra, it's going to get a positive charge in the end. So hydroxide ion is your conjugate base, and conjugate acid, so the caffeine, the product, if you will, is going to be a conjugate acid. All right, so if you have any questions, please let me know. Thanks. Hit that like and subscribe and all that stuff, blah, blah, blah.